Okay, so this is also going to be homework too, and we'll work through some of it together. And then what's not finished is also part of homework. You got a couple days to do it though. The numbering on this one got off a little bit, so there's two number 10s, and so we're going to adjust that. We'll make that 11, 12, 13, 14, 15. So that means homework goes up to 15, not 14 now, okay? And if you look at the title here, it says proving triangles similar. So there is a little bit of proving. It's not nearly as intense as we've seen in the past with proving. Like last unit was the pinnacle of proving for us, and now we'll still show up here or there, but we're going to look a little bit at proving today, okay? All right, and what I talk about today for proving is all there is in the whole unit on proving. So just as we proved triangles congruent, and there were 5 ways to prove triangles congruent. What were the 5 ways? Side, 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 angle, side, and okay. Those were the only 5 ways we had to prove triangles congruent, and we use that a lot, right? So we can also prove triangles similar, and we can do that with less information than what we have here. And there are only 3 ways. So there's the angle, there's a side, 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 but that's going to be different than our side, 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 because remember, sides of similar triangles are not congruent, they're proportional. So how do we show side, side, side? We'll talk about that. Angles are congruent, so that'll be the same way we've worked. But when we get to the sides, we've got to do something different. So let me give you an example of each here. Let's label this triangle ABC, this one DEF. And angle similarity is going to be the most useful and the most common and the most straightforward one. The one you're going to like the most too. It's the easier one. And it actually is a powerful one. So this is just saying, hey, if I know that angle A is congruent to angle D, and if I know that angle B is congruent to angle E or F, doesn't matter, I'll say E, then that's all I need to say that these two triangles are similar, which means that the third angle is also congruent, which you guys can, does that make sense to you? If all 3 have to add up to 180. But it also says what we haven't looked at, the sides are proportional. And we don't even have to touch the sides to get that. So if we just have the angles, we get similarity. So because angle A is congruent to angle D, and angle B is congruent to angle E, that's all we need to say that triangle ABC is similar to triangle DEF. If triangles are congruent, can we say that they're similar? Can we say that all congruent triangles are similar? Well, are the angles congruent? Yes. Are the sides proportional? What's the scale factor on congruent triangles? 1, right? So you could say congruent triangles are similar with a scale factor of 1. Okay. Are all similar triangles congruent? No, most of them aren't. Okay. All right, so side, side, side. Here we know nothing about the angles. We just know about the sides. So let's say we had this, starting with a larger triangle, say we had 20, 15, and I don't know, 10. Okay. And over here, let's go with 4. What would this one be? And, okay. What would my scale factor be going from large to big? Or sorry, large to small? 5? So that means you multiply all these by 5 to get here. You multiply by your scale factor. So we're actually getting smaller numbers, so we're going to have a fraction here. So our scale factor going from left to right would be 1/5. Now, if we started with the small triangle and I said, what's the scale factor from the smaller triangle to the larger triangle, then you'd say 5. Okay. So our scale factor is 1/5. And, if ever you're searching for a scale factor, all you have to do is find two corresponding parts and say, well, 15 times what equals 3. Solve that. Okay, so x is 3 over 15. Reduce it 1/5. You get your scale factor. Because the scale factor is what you multiply these things by to get the new value, right? So to show side, here, here's all we would have to do. Let's say A, B, C, D, E, F. We'd have to say, okay, well, AB divided by DF, okay, the two sides that we think correspond, okay, this side divided by this side, that, whatever that reduces to, has to be proportional to the other sides as well. So, what's that? I meant DE, yeah, sorry. So AB over DE has to be the same as BC over what? BC corresponds with EF, and whatever those equal also has to correspond with, so AC over DF, okay? And if you take any of those fractions and reduce it, what are all of those going to reduce to? What's that? 1, really? Well, let's look at AB. AB is 20, DE is 4. What's that going to be? 5 over 1, right? So all of these are going to end up being 5 over 1 or 5, okay? If I could go the other way, I could go DE over AB, then you'd have 1/5. But you see how that's kind of related to the scale factor. So you'll either get the scale factor or it's reciprocal when you do this, okay? If you want side angle side similarity, the angle has to be in between the two sides, okay? Just like we had with congruence. So if I knew that angle B and angle E were congruent, then I'd have to show that AB and DE, AB over DE, is equal to what? So this was 7, this was 5. Okay, AB over DE is what over what? BC over EF. Okay, and what would the scale factor be here? Going from left to right. So if I wanted to multiply the values in this first triangle by something to get the values in the second triangle, what might be my scale factor? 5 over 7, because you're thinking this, 7 times what scale factor equals 5, and you divide by 7, you get 5 over 7. Okay. And so if you're able to show this right here, you'd get side angle side similarity. Okay. All right, so the next few problems are going to ask us to determine how the triangles are similar and include some kind of similarity statement. I'm going to do one with you. Okay. Are these two triangles similar? We got AA, SSS, or SAS. Which one can we use here? Angle, angle. So which angles are congruent to which angles? C is congruent to GY. So we got alternate interior angles are congruent, right? We could also say angle F is congruent to angle D for the same reason. And now we already have angle. But then you may see, well, we got vertical angles too, right? Why or what? Because those are alternate interior angles as well. Okay. So we have more than enough. We have AAA. We only need AA. So determine how the triangles are congruent. That's AA similarity. And then include a similarity statement. A similarity statement is saying one triangle is similar to another. So triangle DCE is similar to which triangle? Order matters. FGE. Okay, good. Number 2, I'll leave for you. Let's look at number 4. So I want to show that two triangles are similar here, and we could use angle. We could use side, or we could use side. Which one would you want to use? What's that? Angle. Could we get it? How? Did we get angle on this thing? They share an angle, W, right? Overlapping, the smaller triangle has angle W, the larger triangle has angle W. Is there another angle that we can face congruent? We don't have anything that indicates that we have parallel sides, right? So we can't do angle. So now, what's that? So we can do side, or we can do side. We're going to side angles, the less number of sides we use, let's do side angle side. Okay, the more angles you can incorporate, the better. So I'm going to draw two triangles that we think are similar. I'm going to separate them because they're overlapping. Okay, so we know that angle W is congruent to angle W by what? Reflexive property of congruence, okay? The side lengths of the smaller triangle are 1/2, 1/3, and 1/4. The side lengths of the larger triangle, UY is going to be 2/3. What's WY? Yeah, you're going to have to add them, huh? So 1/3 plus 5/9. So 1/3, if you want, you can multiply top and bottom by 3 to get a common denominator. So that's going to be 3/9. So 3/9 plus 5/9 is 8/9. Okay. And if you look at WU, again, you need a common denominator, which is 6. So multiply top and bottom by 3, and you get 3/6 plus 5/6, which is 8/6. Okay. So now we have our two triangles. If I want to show, if we want to use side angle side, what am I going to have to show here? That WV over what? WU is equal to what over what? WX over WY. Nobody said VX or UY. Could we use those? No, we can't. Why not? Because we're working with side angle side, right? And so we have to use the sides that are connected to that angle. Okay. So let's find out what each of these are separately and see if they equal the same thing. So WV is 1/2 divided by WU, which is 8/6. And when you have a fraction divided by a fraction, remember how to do this? You multiply the top fraction by the reciprocal of the bottom part. And we end up with 6/16, which reduces to 3/8. Okay, so that's that. That's this one. And now let's check the second one. And if we get the same thing, if we get 3/8 for the second one, then we know they're proportional, right? If we don't, then we've just proven that they're not similar. And sometimes I'll throw in something that's not similar, so you have to check. So WX is 1/3. WY is 8/9. So that would be 1/3 times 9/8, which is 9/24, which reduces to 3/8. So again, we have that both of these are 3/8. And so now we've proven that they're congruent. Sorry, they're similar by side angle side similarity. So you have to show that kind of work. Okay, you have to work through that. And so the more sides you have, the more work you have, right? And so you want to go after angles first if you can. Yeah. So you could. How would you do it? Mhm. Yeah. So if it's gonna, you could do cross multiplication, and if you do that, you're just gonna check that your left side is gonna equal the right side after you cross multiply, and that would work. Yes. Okay. And that might be a little shorter too for you. Okay. All right. Let's now take a look. What would you rather do, 6 or 7? 6? 7? Okay, let's do 7. So on 7, notice we have parallel. And parallel is going to give us congruent angles somehow. Do you guys see what angles we could say are congruent? This angle here is congruent to this angle here. So angle M, we can't say angle P because there's a lot going on there. So we're going to use 3 letters, angle R, P, Q. And why? Corresponding angles. Okay. And we're not meaning corresponding angles of congruent triangles. We're talking corresponding angles from this parallel cut by a transversal. Okay. They're in the same corner. They're congruent. And so we're going to do a similar thing here. We're going to try to show a side angle side similarity. That's our, because we have an angle, we got 2 sides that we're working with. So we'd like to show that MC over what? PR is equal to, careful, what? MP over MQ. And MC is 3√2. PR is √3/2. We want to see if that, I'll put a little question mark here. Is that equal to MP, which is 4√18, over 2 root 3. Okay? And so we mentioned cross multiplication as another method, and so I want to demonstrate that here. So if you want to use cross multiplication, so you have a choice. You could separate these fractions and see what they both reduce to, and see if they reduce to the same thing. Or if we do cross multiplication, what's going to happen is we're going to check, is the left side equal to the right side? Okay, and so we'll try that out. So cross multiplication, we'd say, well, is 4 root 18 times root 3 over 2, is that equal? I'll put a little question mark because we don't know yet. Is that equal to 2 root 3 times 3 root 2? So we got to remember some stuff about this, right? How do we multiply 2 root 3 and 3 root 2? The right side. What would you get if you multiply those together? Remember how to do that? Do we need the same root to multiply? No, that's only for adding and subtracting. For multiplying, you go 2 times 3, the stuff on the outside, and then square root of 3 times 2. You can multiply everything together, but you got to stay within its own kind. Okay. So 6 root 6. On the left side, let's work at that a little bit. We got 4 root 18 times root 3 all over 2. And then the 4 and the 2 can reduce, right? And we could multiply the 18 and 3, or we could just do this. This is 2 times the square root of 18 times 3. And let's try to break this down a little bit more. 18 is 6 and 3. So we got 3 times 3 times 2. All those are coming from the 18. And then we also have this 3 here. Okay. And so we got 2 3s that we can pull out. And we're going to be left with a 2 and a 3 underneath. And so on the outside, we'll have a 2 times 3, because there was already a 2 on the outside. We pull the 3 out, and what's left is a 2 times 3 on the inside. And that's going to be 6 root 6. And notice that they're matching. Whew. All right. So we showed that this proportion is true. We also convinced ourselves that the angle in between those sides are congruent. And so now we have side angle side similarity. So let's finish off by similarity statement. Triangle MCP is similar to which triangle? PRQ. All right. Let's go look at some proofs. So proofs tend to be pretty simple with similarity, at least the ones I'm going to give you. Obviously, there are complex proofs out there. The most complicated one that you'll ever see for similarity is number 11 here. So we could do that one together, or I could save that one for you. You want to do it together? Okay. So let's first talk through this. We want to show that VKR is isosceles. Any idea how we could do that? Find VK. Show those are the same, and we got it. Right? You see a way of doing that? Okay, so if we can show that the base angles of that triangle are congruent, then we can use the converse of isosceles triangle theorem. How can we get to the base angles are congruent? You have to show that triangle PQR and triangle STV. If we show two triangles are similar, that means all the angles are congruent. There's our plan. So show that two triangles are similar by either angle or side or side by side. After we show they're similar, we say, you know what? That those two base angles of that isosceles triangle, I don't know if isosceles yet, but those two base angles are congruent. We say therefore that's our direction. What do you think? How are we going to show these two triangles similar? Which one are we going to use? Okay, so if you look at what's given, we definitely have an angle congruent to an angle that we can get to. It's not given to us explicitly, but we can get to it. And then if you look at the proportion, I'm going to highlight what's in here. So we have PQ over ST, so saying that those are corresponding. And they're saying QR and VT are proportional as well. And so they've already established the hard part for us, which is the proportion. All we have to establish is that the two right angles are congruent to each other, which we've done that before, and we can do that. And we can say they're similar. Okay, so let's write it up. The statement, reason. So our givens are PQ perpendicular to QT, ST perpendicular to TQ, and they give us PQ over ST is equal to QR over TV, and that right there did a lot of work for us. That was all the work we were doing on the other ones where we had to establish that. They've already established that for us. So we already have the side and side. We just need the angle in between. That's all given. So all we have to argue now is that we have an angle congruent to an angle. So what should our second statement be? Angle PQR is congruent. Well, we can't jump there yet. What do we have to say about it? It's a right angle. So let's first say it's a right angle. And so is STV, right? Why are they right angles? Because it says they're perpendicular, and definition of perpendicular says that we got right angles. Okay. So that comes from step 1. And then we can say that they're congruent to each other. Why? All right angles are congruent. And that came from step 2. So now from congruence for the angle and for that proportional statement, those two things establish that the triangles are similar to each other. So we could say triangle PQR is similar to triangle what? STV. Why? Side angle side similarity. All right. Usually that's where the proofs will stop for you guys. And that will be like the hardest type of proof you'd encounter. Okay. This one goes a little further. And that's why I said, okay, this is the longest one we'll see. But usually that's about as long as the proof we'll have. So now we want to go a little further and say that angle KVR is congruent to angle KRV. Why? Now we can't say CPCTC because that means corresponding parts of congruent triangles are congruent. But we could make our own variation of it. Well, how would the variation be if we had to say it out without abbreviating? Corresponding angles, not sides, corresponding angles of similar triangles are what? Congruent. So if we happen to make an abbreviation, what would it be? There is none out there. CASTC. I've never seen that ever used before, but we could see where it would come from. Okay. So then we established the base angles of that triangle are congruent. So we can now say that the side lengths are congruent, that VK is congruent to RK. Why? Converse of the isosceles triangle theorem. And now we finished it. We say that triangle VKR is isosceles. B by definition. So again, most proofs are not this long. Most of them would end like at step 4. But even this one's not too bad once you see it. So I want to do one more proof with you, and then I'll leave the other ones for you to do. I'm not going to do. I'll leave 12 for you, but 12 is going to be a simple one, maybe a 2 or 3 step proof, and you can kind of see where you're headed, right? Can you see why those would be similar? Angle somehow, right? And I'll leave that one for you. But I want to look at 13, 14, 15. 13, 14, 15 have the same diagram, and it turns out this diagram is really important to know and understand. What we're going to learn on Friday relates to this diagram. And what we have here is a right triangle with an altitude. Okay, and that altitude forms 2 other right triangles. And it turns out that all 3 right triangles that are there, everybody see all 3 right triangles? Got the big one, and then the 3 small ones that are divided in. All 3 of those right triangles are similar to each other. And so that's what 13, 14, 15 explore. On 13, I'm saying, let's show that the small one for HTG, that small one there is similar to the big one. On 14, I'm saying, well, let's see, how about the CBD? The one on the right is similar to the big one. And then on the last one, let's show that the 2 smaller ones are similar to each other. It's not too hard. These are not too hard to do, but it's a really important result. Okay. I'll do one of these with you, 13, 14, or 15, doesn't matter to me. Take it by request. 13, I heard. All right, let's go 13. It's not that one's harder than the other two, so they're all about the same difficulty. So 13, we want to show the triangle ACD, and even try to work a little ahead of me. We want to can we explain why this one is similar to ABC, this one here? And I encourage you to separate them. Okay. Guess how we're going to show they're similar? Angle, angle. We have no side lengths at all, so we cannot do anything with sides. So can we get two angles, two pairs of angles congruent? So what's something we have here? Okay, they both share. Whenever you have overlapping triangles, you have they share something. So they both share angle A. And what's the other one? They both have a right angle. And so we just kind of put that in the proof, and we've proven it, right? So it's going to be a really short proof. And so let's put the givens. Oh, by the way, there's a mistake on all of these. Anybody see a mistake in the given? It should be A, C, B, not, yeah, so all these should write angle A, C, B. My mistake. Okay, so we're given that we have a right triangle, angle ACB is a right angle, and CD is an altitude. You guys remember what an altitude is, right? Yeah. So we want to establish angle, angle. So what can we put for step 2? Angle A congruent to itself. Why? Okay. What else can we say? Okay, so we already have one of them. We got ACB is a right angle. We just need the other one. So angle, what's the other one? ADC. Angle ADC is a right angle. Why? Definition of altitude. Okay, so now we have that both the ones that we want are right angles. So what can we say for step 4? No, we can't say angle, angle because we've only showed one angle congruent to one angle. We need two of those congruent statements. Angle ACB is congruent to angle ADC. That's what we need right there. And why is that? All right angles are congruent. Okay, so let me pause here. Step 3 came from step 1. Step 4 came from steps 1 and 3. Okay, so now we have step 2 and step 4 establishing angle, angle. So what can we say? Actually, we're done with the proof with this last, we got one more statement. Finish it off. Triangle ACD, similar to triangle ABC. Why? Angle, angle similarity. And that came from steps 2 and 4. Again, this is about as hard as those proofs get. But let me show you something in this picture that may not be as obvious. What's congruent to angle B? This one right here. Right? That's what we just showed. We said the two triangles are congruent. We said leaves us with that angle. So I'll stop there. You guys got about 15 minutes to work on homework, ask questions.